What if the Big Bang wasn't the beginning of everything? What if it was just a spark, a tiny ripple in a much bigger ocean? For decades, we've believed that the universe began with a singular explosion, the Big Bang, a moment when all of space, time, matter, and energy burst into existence. But what happened in the first trillionth of a second after that explosion? The truth is, we don't really know, not for sure. But there's one theory, so bold, so strange, yet so brilliant, that it might just explain everything. A theory that could solve the greatest mysteries of the cosmos. A theory that says the universe didn't just expand, it inflated, faster than the speed of light. And if that's true, then our universe, this one we call home, might just be one bubble in an endless cosmic foam multiverses. Infinite realities, versions of you, living lives you'll never know. Sounds like science fiction? It's not. This is the story of cosmic inflation, the silent, invisible force that may have shaped reality itself, and it all began before the beginning. The Big Bang Theory changed everything. It told us that the universe began with a single dense point, a singularity, and has been expanding ever since. And for the most part, this model works. It explains the cosmic microwave background. It explains the abundance of elements like hydrogen and helium. It fits the expansion of galaxies. But there's a problem. Actually, three big ones. First, the horizon problem. When we look at the cosmic microwave background, the oldest light in the universe, it's almost perfectly uniform in every direction. But here's the thing. Those regions are so far apart, there's no way they could have ever communicated. No light, no heat, no information could have traveled between them in time. So how did they end up with exactly the same temperature? Second, the flatness problem. Our universe appears incredibly flat, geometrically speaking. But that's only possible if, at the very beginning, its energy density was fine-tuned to an absurdly precise degree. Why? Coincidence? Or something deeper? Third, the monopole problem. According to grand unified theories, the early universe should have been filled with exotic particles like magnetic monopoles, particles with only one magnetic pole, but we've never found any. Not a single one. 3 deep mysteries. And for years, no one had an answer. Until someone proposed something radical, a moment of expansion so fast, so powerful, it would change everything. In 1980, a young physicist named Alan Guth sat late one night at his desk, staring at a blackboard filled with equations. He was trying to solve one of those impossible cosmic puzzles, the mysteries left behind by the Big Bang. And then, he had an idea. What if, in the tiniest fraction of a second after the Big Bang, the universe didn't just expand, it exploded outward at an exponential rate? Not because of matter, not because of heat, but because of something far stranger, a field of energy locked in a state of immense potential. This, he called cosmic inflation. Imagine the universe when it was smaller than an atom, smaller than a proton. And then, within 10 to the minus 35 seconds, it stretched to the size of a grapefruit. That's a trillion times bigger, in less than the blink of an eye. During that moment, space itself expanded faster than the speed of light. Not the objects inside it, but space itself, stretching reality like a balloon being blown up. And this incredible burst of expansion did something extraordinary. It smoothed out the universe, explaining why distant regions have the same temperature. That's the horizon problem solved. It flattened the geometry of space, making our universe appear so perfectly flat. Flatness problem solved. And it diluted away the magnetic monopoles, scattering them into oblivion. Monopole problem solved. But there's more. Quantum fluctuations, tiny random jitters in that early energy field, were stretched out too. Those microscopic ripples became the seeds of everything we see today. Stars, galaxies, clusters, even the web of the cosmos itself. From chaos came structure. From nothing came everything. Cosmic inflation didn't just explain the Big Bang, it refined it. It turned chaos into order, randomness into the architecture of the universe. And yet, Alan Guth's idea was only the beginning. Alan Guth's idea changed the game, but it wasn't perfect. There was a problem. How does inflation end? How does the universe stop inflating, cool down, and begin forming stars, galaxies, life? This became known as the graceful exit problem. Enter Andrei Linde, a Russian physicist who took Guth's concept and pushed it further, much further. He proposed a new version, chaotic inflation. In Linde's model, inflation doesn't need perfect conditions or symmetry. In fact, it can begin in a wildly chaotic state, full of quantum fluctuations and randomness. And here's the twist. Once inflation starts, it never really stops. It might end in one region of space, where a universe like ours forms, but in other regions, it keeps going. This means that while our universe settled down and cooled, other parts of the cosmic fabric were still inflating, creating more and more bubble universes. Each bubble with its own laws of physics, its own constants, its own beginning. This is the multiverse. Not just science fiction, but a serious, if controversial, consequence of inflationary theory. Think about it. Somewhere, there may be a universe where gravity is weaker, where stars never formed, or where life took a completely different path, and somewhere else, there could be a version of you making completely different choices, living a different life. Infinite versions, infinite realities, born from one idea, that inflation doesn't stop, it spreads. This vision of reality is as breathtaking as it is disturbing, because if it's true, then our universe is not the whole story. It's just one page in an infinite cosmic library. Cosmic inflation is one of the most elegant theories ever proposed. It explains the biggest problems in cosmology with stunning simplicity. It predicts things we can actually observe, like the uniformity of the cosmic microwave background. And yet, not everyone is convinced. The first challenge: we've never directly observed the inflation field, the mysterious energy that supposedly drove this rapid expansion. Without detecting it, how can we be sure it existed? Second, the theory predicts a multiverse, but other universes, by definition, are outside our observable reach. If we can never see them, touch them, or measure them, is that still science? Some argue the multiverse is more philosophy than physics, a beautiful idea, but untestable. Third, even within our universe, the evidence for inflation is mostly indirect. Yes, the cosmic microwave background supports it, but we're still looking for more definitive signatures like primordial gravitational waves, ripples in space-time left behind by the inflationary burst. We thought we found them once. In 2014, the BICEP-2 experiment made headlines claiming they detected them, but it turned out to be cosmic dust. Inflation remains a powerful idea, but not yet a proven fact. And that's the beauty of science. Theories must not only inspire, they must survive the evidence. Cosmic inflation may be invisible, but its fingerprints might be written across the entire universe. It's a theory that reshapes our understanding of space, time, and reality itself. It shows how the smallest quantum ripples could sculpt entire galaxies, and how our universe may be just one of countless others, born from a surge of expansion that never truly stopped. Whether you believe in it or not, inflation challenges us to think beyond what we can see, to imagine a reality much bigger than ourselves. Maybe the universe isn't a single story, but a library of stories, infinite, strange, beautiful, and perhaps, one day, science will let us read more than just the first page. Until then, keep questioning, keep wondering, keep looking up. If you found this fascinating, don't forget to like the video, subscribe, and hit the bell icon so you never miss a cosmic mystery. And now it's your turn. Do you believe in the multiverse? Could there be another version of you out there? Let us know in the comments below, because the universe is vast. But curiosity is even bigger.